Hi, hello guys. This is Vijay, chemistry lecturer from Alaba Junior College. As you know that we have started our NEET series. Based on that, we are discussing about NEET chemistry and NEET biology. This both subject in detail each and every chapter. Okay, in that category today we are going to discuss about Unit 3 classification of elements and periodic properties. Okay, let's start. Now, let us talk about Newland's Octaves law. Yes. So, Newland's Octaves law. This is one of the a method of the contribution of the great English chemist John Newland in the year 1865, who put effort for the classification of elements based on certain grouping of element. Okay. Let us see how far this Newland's law of octaves been framed. Okay. So Newland, who proposed a new system of grouping of these elements of the similar properties. According to him, he made the elements based on the musical notation. The musical notation, usually that could show like the first letter that could be repeated frequently after the eighth letter. Say for example like sarigama. Okay, sa, ri, ga, ma, pa, da, ni, and again repeating for sa. See, so this is like a musical notation, sarigama, bada, ni, sa. In that you can see there the first letter, that is sa, and ri, second letter, ga, third letter, ma, fourth letter, pa, fifth letter, da, sixth letter, ni, seventh letter, and the eighth letter is again the first letter which is going to be repeating. Okay. So this is a peculiar type of musical note. No, sa, ri, ga, ma, pa, da, ni, and finally it is again repeating with the first letter sa. So based on this musical notation, Newland's octaves law also been framed. For example, when the elements which are arranged in the increasing order of atomic weight, its properties of every eighth element which would show the similarity of the first element. So this is what the Newland's octaves law based on the musical notation. Okay. Now, let us see few examples for this particular type of arrangement of elements. There are few elements we have to be considered here. Elements like lithium, barium, yes, next boron, carbon, nitrogen, oxygen, and again fluorine. Okay. Now, let us see in this particular sequence: lithium, beryllium, boron, carbon, nitrogen, oxygen, and fluorine. And again it is going to be repeated with lithium, and again it is going to be repeated with sodium. So these are said to be these elements are having the metallic properties, right? Similarly, if you continue with the one more set of the arrangement of these elements like sodium, magnesium, yes, Mg, and aluminum, silicon, phosphorus, sulfur, and chlorine, and again it is going to be repeating with one more metal, that is called potassium. Okay, potassium, then followed by calcium. See here, these three are repeating for every eighth element: lithium, then followed by 1, 2, 3, 4, 5, 6, 7, and eighth element, that is sodium. Similarly, sodium, from the sodium if you count 1, 2, 3, 4, 5, 6, 7, and eighth element, that is potassium. So these all are having metallic property. Similarly, you can see consecutively every elements, they could show the properties of every eighth element. Say for example like counting from fluorine, 1, 2, 3, 4, 5, 6, 7, eighth element, that is chlorine. Fluorine, chlorine, they could form the gaseous element. So like non-metallic element they are. So This Newland's law of octaves that could explain in detail about arrangement of every elements based on that musical note. In the musical note we can able to see the first letter that is going to be repeated for every eighth letter. Similarly, the first element according to Newland's octave law that could be repeating for every eighth element. Okay, that could show the similar properties and also the similar characteristic features. Okay, so far this particular type of arrangement been called as Newland's law of octave. So octave stands for 8. Now every consecutive elements they are repeating with their physical and chemical property and characteristic features. Okay, then why this Newland's octaves law is not very familiar or it is not very famous to be considered? Because this particular law also based on the arrangement of classification of elements could show the effort but it could failed. The reason is these consecutively repeating of these 8 elements also can be able to see for few elements only, not the entire 118 elements. The reason is the rest of the elements that could show the variation in its atomic weight and also atomic number and their properties as well. That is the reason this could be possible only for few from the beginning of few elements that could obey for this Newland's octaves law. Then that is the reason this particular law is again to be not considered. Okay, so now let us talk about Lothar-Meyer's classification or Lothar-Meyer's arrangement. Okay, now let us talk about this particular type of arrangement. In the year 1869, yes, a German chemist whose name is Lothar-Meyer, who used the physical properties only to be considered for arranging of the different types of elements based on his classification. Say for example, like there are few physical properties like atomic volume, melting point of the element, boiling point of the element. Okay, so these all physical characteristic features are the physical properties he has been considered for arranging of the elements. So according to him, he showed that when the properties of these particular elements which are like the physical properties such as atomic volume, melting point, boiling point, these all to be plotted as a function of their atomic weight. See, the element's atomic weight to be considered based on the physical properties he believed. That is the reason he could consider for this particular the physical properties as his one of the major note for making of classification of different type of elements. Okay, Lothar-Meyer who proposed that when the elements which are arranged in the increasing order of their atomic weight that could show the similarities in physical and the chemical properties appear at a regular interval, but this also could be failed. It is also not well familiar because this is possible only for few elements, but this which is not showing in rest of the element, and that is the reason this particular method of classification also not shown well effort. So now finally we are going to consider that based on the historical classification of elements, these are the major people those involved for to show their effort for making of or the classifying of the different type of elements and trying to make a platform for the development of periodic table. Okay, now let us talk about Mendeleev's periodic law. Okay, so according to Mendeleev in the year 1869, okay, in the year 1869, Mendeleev who made a remarkable contribution to the classification of elements on the basis of the physical and chemical properties of the different types of elements. So this is popularly known as periodic law of Mendeleev or Mendeleev periodic law. According to this law, the law that could state that the physical and the chemical properties of the elements which are the periodic function of their atomic weight. See, the elements which possesses their atomic weight, that is based on the physical and chemical properties of each and every element and its periodic function. Okay. So, this could explain that when the elements which are arranged in the order of their increasing order of atomic weight, the elements with the similar properties recur at regular interval. Such orderly recurring properties in a cyclic fashion or a cyclic manner, which are said to be periodicity or periodically. And this is responsible for the name periodic law or the periodic table. And this entire credit goes to Mendeleev. Okay. So on the basis of this periodic law, Mendeleev, who arranged all the known elements in the form of a table, that table is considered to be periodic table. It was observed that the elements with similar properties recur at regular intervals or periodically. Okay. As a result, the elements that could fall in certain group or certain families, so based on that the elements being classified. Now you see the properties that could be repeated periodically, and Mendeleev, who could published his periodic table in the year 1905. So he could publish his periodic table in the year 1905 that could given the table in detail about the arrangement of the elements based on the physical and chemical properties and also the atomic weight. Okay. So according to Mendeleev periodic table, the table could expresses about two different, rows or column. Say for example, like the horizontal rows which is present in the periodic table, which are called as periods, and the vertical columns which are said to be groups. Okay. Mendeleev's system of this classification of the elements that was more elaborated than the earlier attempt of this classification of elements and periodic properties. He realized that some of the elements that did not fit very well with his scheme of classification, but majority of the elements that could obey for his framing of the classification and the framing of periodic table. Okay. Then he placed the elements with similar properties all together. Say for example, like iodine that could has the lower atomic weight than comparing with tellurium, okay, which is present in group 6th. But he placed iodine in group 7 along with fluorine, okay. Chlorine and bromine and fluorine, these all could show the similarities in their properties, where he could able to place this iodine. So chlorine, fluorine, bromine, iodine are being placed in a set of row, and that could shows that the properties of the similar properties of the different elements. So also the Mendeleev classification that could gave him so much confident about gap or the space that being filled with the undiscovered element, but that could shows the similar properties as he believed. Okay, as considering that properties of the adjacent element in the periodic table, he predicted that the properties of the undiscovered elements also to be the same. That could be achieved later on when the particular elements were being discovered. Their properties that could able to match with the elements which are already were discovered. Say for example, gallium and germanium. These two were not discovered at the time of when the Mendeleev who could able to frame this periodic table, but he left gaps for these elements, and he also predicted that these elements to be discovered in the future, but that could show the same or the similar properties as which is present in the earlier elements. So he tentatively gave a name for such an elements as Eka aluminium and Eka silicon. See, this Eka, that is in Sanskrit to be called as next. So he believed that the next element should be this particular type of element, and that could possesses the such a type of atomic weight and atomic number, and also the same physical and chemical properties of the previous element. Okay, so according to Mendeleev, his periodic table was one of the greatest achievement in the development of chemistry, and some of the important contributions of his particular periodic table, let us see one by one. First one, systematic study of the element. Mendeleev periodic table contributions. So first one is systematic study of element. So according to Mendeleev periodic table, the first and fourth most important contribution is systematic study of the elements. Okay, this Mendeleev periodic table that could able to give a simplified form of the study of the different type of elements, knowing the properties of one element present in a particular group. Say for example, like chlorine, fluorine, bromine, iodine. In that, in any one of the particular gas, we are going to study in detail about the gas detailed study or the physical and chemical properties of the particular element. Almost that could show the similar effectiveness of the rest of the element present in that particular group. So knowing the properties of one element, we could able to understand the particular group of the other elements as well. This it could give us a very useful manner for studying and also for doing research based on the particular type of elements. Okay, now next one we are going to talk about the another contributions of Mendeleev periodic table, that is correction of atomic masses. Correction of atomic mass or atomic masses or atomic weight. Okay, so according to Mendel, he could also made the table. That table could help us to correcting the atomic mass of some of the elements based on their positions in the periodic table. Say for example, the atomic mass of beryllium that could be corrected from 13.5 to 9. Similarly, with the help of this particular table, the atomic mass of indium, gold, platinum that also been corrected. So this could help us to study the particular type of elements in detail. So correction of atomic masses could be possible by Mendeleev periodic table. Finally, we are going to talk about the most important contributions of Mendeleev periodic table, that is prediction of new elements. Prediction. So at the time of Mendeleev period, only 56 elements were known. But while arranging all these elements, he left some gaps or the space. He believed that these gaps are the space to be filled. In the future, there must be possible like the discovery of new different types of elements, and that could fill in these particular gaps or the space. And these particular gap that represented the undiscovered elements. So Mendeleev, he could predicted that the properties of these particular undiscovered elements on the basis of their position present in the periodic table. Say for example, he predicted that the properties of gallium. So he could able to predict the properties of gallium, that is to be called as Eka aluminium, and germanium, Eka silicon. These were the name given by Mendeleev in previously, and the meaning of eka, which is stands for in Sanskrit, that is called as next. So in the future, what happened, these elements being discovered and they were given with their different names such as gallium and germanium, and these were discovered later. The observed properties of these particular elements were found to be similar to those of the predicted characteristic features by Mendeleev. So based on that, he could able to made the prediction of new elements going to be discovered. So this is also one of the most important contribution by Mendeleev periodic table. Though he had a lot of the effort for framing of this periodic table by Mendeleev, but there also been few defects when he was framing this periodic table. Those defects let us talk about next class. Okay. So far, guys, we have discussed few topics from Unit 3 classification of elements in detail, and this particular unit we are going to continue with few more new topics. Until then, thank you guys.